Sorry. So I never thought I would be making a video on this because it seemed so simple, so trivial. But then I did not study group theory or algebra for like 2 months, and I had a hard time figuring out how to find the order of elements, how to find how many elements are there, what kind of elements are there. So it was all fading away slowly, so I had to recollect it. So I thought it is important to make a video. So let's begin. Symmetric group, also called the bijections from n to n. Basically, let's say n is 3. So we have A, B, C here, A, B, C here. So number of bijections from this set to itself. That is what this group represents. Okay, and so how many number of bijections are there? See, A, it is basic permutation and combination. A has 3 options. So if A is mapped to 1 and we are looking for bijection, B will have 2 options. A has 3, B has 2, C has 1. So in total we have 6 ways, 6 bijections. And that is the number of elements in this group, n factorial basically. Okay, now coming to the elements. I'm hoping you already know how these look. But okay, let me draw ones. Like, we'll start with an example, S3. By the way, I'm sorry, I'm making a video after an extremely long time. I was occupied. So, yeah, apologies for any pauses and anything that you don't like about this video. Anyway, S3, 6 elements we said. So what are those 6 elements? Now, there can be 3 types of elements. 3 cycles. I hope you already know this. Then 2 cycles and 1 fixed, and then all fixed. Okay, let me explain it with this once, and then we can put it to rest. Say these. So these are, okay, I'll use this itself. What is happening is this represents the identity element of this group. So A goes to A, B goes to B, C goes to C. Mathematically, we are used to seeing it as this. No, I'm sorry. Not like this. Just 1. 1 goes to 1, 2 goes to 2, 3 goes to 3. This is how it is written. Basically, we just write it as E, right? Now, the next one, 2 cycles, these, they are like, one of them is kept fixed and the other 2, they permute. Okay, so instead of ABC, let's change it to 1, 2, 3, because that is the concept we are familiar with. But it can be anything. These are the symmetric groups. As far as my knowledge goes, it is used in studying chemistry, structure of atoms. Is it? No, that is dihedral. That is dihedral group. Anyway, I'll skip that part. A little knowledge is a dangerous thing. Anyway, so coming back to this, two cycles, these are called two cycles. So one element is fixed. Say we fix one goes to 1, and then 2 and 3 they permute. So 2 goes to 3, 3 goes to 2. We write it like this: 2 goes to 3, 3 again goes to 2. So we close the cycle, and then 1 is here. We can either write it or skip it, does not matter. Similarly, we can fix 2 and 1 3 can permute. Then we can fix 3 and 1 2 can permute, right? These are called two cycles because this is how we write it, right? These are also called transpositions. Okay, and yeah, now let's move to the third one, which is these three cycles. How many ways is this possible? Well, all three have to permute. So, okay, let's go by the basic approach 1, 2, 3. Now we know that they can permute in 3 factorial ways, right? But we also know that that is the total number of elements in S3. So what happened? Well, the thing happened is that if we are taking this 3 cycle, 1, 2, 3, which technically says that 1 goes to 2, 2 goes to 3, and 3 goes to 1. This is what this represents. So this 3 factorial, this is taking in consideration 2, 3, 1 and 3, 1, 2 as well. When we do this, all these 3 are counted. All these 3 are counted in this. But these are basically the same thing. This is just, and this is the same bijection written in a different, this is the same element written in a different way, right? Yeah, it is a bijection indeed. Okay, it is just written in a different way. So we don't have to count it 3 times. Okay, so we divide this by 3 to remove this repetition, which gives us 3 times 2 over 3 times 1 over 3, which in turn gives us 2. So there are 3 cycles, which actually are this 1, 2, 3, and then 1, 3, 2, right? Okay, and okay, let me take another example and then I'll come back to this. Let's take S4 now. So S4, possible type of elements. We can have 4 cycles. We can have 3 and 1. Then we can have 2 and 2. Then we can have 2, 1, 1. Then we can have this. This is the identity. Now we know that 4 factorial is the total number of elements in this group. So that is 24. Let's start counting. This is 1. Okay. Now this, since it's a 4 cycle, we'll write 4, 3, 2 times 1. This is product over 4. I explained that how this happens above, 4 factorial ways, and This 4 eliminates the repetitions. So we have 6 elements of this type. Then this, because this is 3, you write 4, 3, 2 divided by 3, which gives us 8 elements. How this is happening, I'll explain you in a while. Let's do the next one first. 2, 2. So we do 4 times 3 times 2 times 1. Now because there's a pair, we divide by 2, a pair, we divide by 2. And because these are of the same size, these two cycles, so we divide by 2 factorial. Remember, this factorial is important. Okay, so I'll explain it in a moment. Just bear with me. This 2 into 2, 4, and this cancels out. So 3 elements. Okay, right. And the one that's left is this 4 times 3, just 2 is there, divide by 2. So 6 elements. Now 6 elements here, 8 here, 3 here, 6 here, 1 here. Let's add them up. 6 and 6, 12 and 8, 20, and 4, 24 elements. Here we have our 24 elements. Now let's understand, what did I just do? So I'll begin with this, the first one. This is pretty obvious. I explained there are 4 numbers, 4 elements in the set. I'm not talking about the element in the group S4. I'm talking about these 4 which are to be permuted. Okay, like in this case, we have 1, 2, 3, 4. 1, 2, 3, and 4. I'm talking about these. We have 4 and we need their arrangements. So it can happen in 4 factorial ways, but each combination, okay, I think, okay, let's write them down. 1, 2, 3, 4, 1, 2, 4, 3, 1, 3, 4, 2, right? Then 1, 4, 3, 2, then 1, 4, 2, 3, and then 1, 3, 2, 4. 1, 3, 2, 4. These are the 6 4 cycles. It is not as easy. I just know there are 6 elements, so I worked like that. Okay, so now what is happening is this 4 factorial is counting this 4 times. How? It is counting, like, see the pattern: 1, then 2, then 3, then 4. So 1, then 2, then 3, then 4. You see the pattern? It is being shifted. 1, 2, 3, 4. This 4 came up front. 1, 2, 3 shifted. 3 came up front. 3, 4, 1, 2. 2 came up front. 2, 3, 4, 1. The same thing I wrote here, right? So these are basically the same cycles, but this 4 factorial counts them 4 times, and it does that with every element. That is why we divide it with 4, right? If you're not getting it, then you need to go and study a little bit of permutation, because that is where it is coming from. And once you do that, it will be pretty obvious. This is really simple as long as you know the permutation and combination concept, which even I did not know actually. I recently studied it. That is why I'm able to figure this out. That this is how it was happening. Otherwise, earlier I just remembered this. The logic behind it was not too clear. Okay, now let's come to this. So what is happening? We are taking three elements. So out of four, we chose three, right? And then the same thing, three cycles, same repetitions for every element. What was happening with four cycles, the same thing will happen with three cycles as well. For example, I'll take just one example. This cycle, 4, 3, 2. This three cycle, then we shift one place. 4, 3, and 2 shifts up front. This. And then 3, 2, 4. These three are not separate elements. They all three of them say that 2 goes to 4. Here also 2 goes to 4. Here also 2 goes to 4. So these are the same elements. But this 4C3 will give us the number in which every three cycle like this would be counted individually. So we divide this by 3. That is why this 3 is there. And 4C3 is what? 4C3 is 4. It is just 4. 4C3 is 4C1. Yeah. Oh, yeah. My bad. See? We have to. 4C3 is just selecting 3. We have to permute them as well, right? And this is to cancel these repetitions. We select 3, we permute them, and then we cancel out the repetitions. I hope this is clear. And now when you evaluate it, it will be 4C3 is 4 times 3 factorial is 3 times 2 times 1 over 3, which is the same as this. 4 2s are 8, right? So this is how it happens. You should apply the same logic to the rest and see for yourself. And now we come back to the order of elements. So basically order of elements is just the LCM of the cycles. Like in this case, this is a 4 cycle, LCM is 4, order is 4. So we have 6 elements of order 4. This is a 3 cycle and a 1 cycle. 1 cycle is basically nothing. We don't write it. So it's a 3 cycle, order 3. How many elements of order 3? 8. Now these 3 elements, these are 1, 2, 3, 4, like this. Because there are only 3, I'll write them down. 1, 3, 2, 4. And then 1, 4, 2, 3. Yeah. These. Okay. As long as these cycles are disjoint, there is no element common, they can commute. You can write 3, 4, 1, 2. I mean, this can be written as 3, 4, 1, 2, or 4, 3, 1, 2, or 4, 3, 2, 1, anything. It does not matter. When, as long as these are 2 cycles, I'm switching their positions because it's a 2 cycle. In 3, I cannot do that. And then I'm interchanging these brackets, their positions, because they are disjoint. There is no element in common. And this is the only time when we can do it. And this is the only time when they will commute, not otherwise. Like if we have 1, 2, 1, 3, they cannot commute. We cannot write it as 1, 3, 1, 2. This basically means 1, 3, 2. This is a 3 cycle actually, and this basically means 1, 1, 2, 3. I hope I'm not wrong. If I'm wrong, correct me. This is basically what it means, right? So yeah, I'll be repeating myself, so I'll stop. Now order, these are 2 cycles, LCM of 2 and 2. LCM of 2 and 2 is 2. So this means that these are elements of order 2. 3 elements of this type of order 2. Then also look at this. Give me a moment. Look at the next 2 cycles, right? This thing again is 2 cycles, but of the form 1, 2. How many are there? 6 are there. 1, 2, 1, 3, 1, 4, 2, 3, 2, 4. Then 2, 4. What is left? 3, 2. That is done. 3, 1 is done. Okay, this should be 6. My mind is not working. Oh, what? Just 1 is left. That should be 1, 4 is there, 1, 3 is there. 3, 4. Yeah, 3, 4 is left. Right? So these 6, these are different. These are 6 elements of order 2, but of this type. And these are, I hope you know, these are a pair of transpositions. These are single transpositions, 2 cycles. So they all are of order 2, just of different type, right? So this is how we find the order, the LCM of the cycles, right? And yeah, one thing I missed, this 2 factorial. See, 1, 2, 3, 4, or 3, 4, 1, 2. This is basically the same. So this 2 factorial is to cancel out the permutation among these 2 cycles, right? Now I will do one more example of S3. I'll just write these and you try and figure this part out yourself if you want to. Otherwise, you know the logic behind this, you can just use it. Just do it a few times and you will get a habit of finding it automatically. Like, you won't have to think. Now, what kind of elements? 5 cycles, then 4 and 1. Oh, I'll not use these brackets because there would be a lot of brackets. Now 3, 2, then 3, 1, 1, then 2, 2, 1, then 2, 1, 1, 1, and then 1, 1, 1, 1, 1. Yeah, this is it. First, I'll write the order. Just a moment. The order of these elements would be 5 LCM of 4 and 1 is 4. LCM of 3 and 2 is 6. LCM of 3, 1, 1, 3. 2, 2, 1, 2. 2. And this is identity. Obviously, the order of identity is always 1. So these are the orders of the elements of this group S5. The order of S5 itself is 125 factorial. And now let's see how many elements are there of order 5. It will be 5, 4, 3, 2, 1 by 5. Use the same logic above. This is 24. Then this next one. Now, because it is S5, I'm starting with 5. Above it was S4. So I was starting with 4. Right? So it depends on the group from where we would start. 4. So 5, 4, 3, 2, just 4 times, and then divide by 4. This is 30. The next one, 5, 4, 3 by 3, then 2, 1 by 2. Right? I'll explain the permutation and combination for this as well later. Okay, so this 3 and 3 cancels, this 2 and 2 cancels, and this is 20. Okay, now this, so 20 elements of order 6, right? 30 elements of order 4. That is what we are doing. Now coming to this 3, so we have 5, 4, 3 by 3, and 1 and 1 that do not matter. You can skip them. This is again 20. Then this 5, 4 by 2, 3 times 2 by 2, and then dividing this by 2 factorial to remove the permutation between them, these two cycles. Okay, this 2 is to remove the permutation inside the bracket, like 1 3 and 3 1, 1 3 and 3 1. This 2 is to remove this, and this 2 factorial is to remove this 1 3 2 4 6, and because these are counted separately, this 2 factorial is to remove this thing. I have explained it quite enough. If you're not getting it, just go through permutations once and it will be much clearer. Okay, so this 2, this 2, this 4, this 2, this 2, 5 threes are 15. So 15 elements of order 2 of this type, but we still have more elements of order 2, which would be this 5 times 4 by 2, which is 10, and then one identity element. Let's just add them. 30, 40, 50, 60, 70, 80, 90, 80, 90, 100, 110. And this 5, 4, and 1 is 10 more. So 110 plus 10, 120. Yeah. This is how you do it. Very simple thing, but still, I thought, why not? Okay, now, yeah, I said I would explain this. What I said about, I forgot. I think it was this. There's nothing to explain actually. We select 3. Okay, I'll do it. See, 5C3. We select 3 first. Okay, let me change the color. We select 3 first, 5C3. Then we permute them. And this is to remove the similar elements. Then 2 are left. We choose 2 out of 2, permute them, and then remove the permutation. Okay, you calculate and this should be same. Yeah, this is same. Is it? Let's just do it. Should be 5 4 by 2 times 3 times 2 over 3. And this is 2c2 is 1. 5 4s are 20. Is it 20? Yeah. So this is how it is done. Okay. Yeah, I hope this is clear. If you have any doubts, ask in the comments. Also, this video is being made after a very long time. I haven't made videos in a while. So if I'm talking slowly or something, I don't know. Just my apologies for that. Okay.